So the next talk is by Hannes Menners, who has been doing a lot of nice security-related stuff in the OCaml ecosystem. And this is on the work on the trust in the software repositories that we use.
Yes, thanks, Gabriel. So this is a talk about Conex, which is a library for establishing trust into data repositories. It is collaborated work with Louis Gesper from OCaml Pro, who's over there. So what is the overall goal here? It is integrity and authenticity of packages, or not even of packages, but more general of data repositories. So what I really want to have in the end is that a client which downloads a piece of data really receives and is sure about that it receives what the author initially released. So that would be a nice property to have if you, for example, install software, that I actually installed the software Gabriel released. So I will focus in this talk a bit more on OPAM, because the idea is to integrate that into the OPAM tooling. But as I mentioned before, it is more generally applicable, so you can use it even without OPAM and for publishing other data sets as well. So what is the OPAM repository? I don't think I think you already know. So it contains OCaml packages plus metadata. I describe as metadata the URL to the tarballs and the build recipes, which are the OPAM, which are inside of the OPAM files. It also sometimes contains arbitrary patches to some tarballs if they don't compile with a newer version of OCaml or so. And the OPAM repository is actually maintained by the community, so it adds new packages, new releases, and there are even people in the community who fix up reverse dependencies and dependencies upon new releases. So there is a very interesting workflow which we have there. What we have in the repositories are several different resources. So we have packages which are identified by a name. This namespace is obviously a resource which is limited, so each package name needs to be unique. Each package itself has multiple releases which are identified by their version. Then we have authors of those packages and or authors of the release, which are usually using an email address or a GitHub identifier, because the OPAM repository is currently hosted on GitHub. And then we have, as was previously mentioned as well, so-called janitors, or I call them janitors, who fix up dependencies and reverse dependencies and merge the pull requests which are submitted by the authors. So the janitors here play a crucial role because they are acting fast, and if we get one of the core packages released, like LWT or so, there might be fixes in hundreds of packages for fixing up the reverse dependencies because there's some incompatibility or so. And we have to take that into account if we design it. So as I sketched out here, actually we have the packages on the left side, and the client on the right side actually wants to know whether the package it received is really the one intended. So whether it's really the blue one he wanted to install and not the red one someone else wanted him to install. What is the security state of OPAM these days? Well, there's not a trusted link between even the client and the repository, so there's TLS connection used, but no certificate validation is done. So a person in the middle can inject arbitrary code and arbitrary patches and arbitrary releases, new packages, whatever. The remote archives only use MD5, which is considered to be weak since several years. Furthermore, single janitors, so one of the guy is responsible, or one of the people responsible for the main open repository, can completely subvert the entire repository. So they can add arbitrary patches and just commit it to the Git repository, and all the users will just install the new version of LWT with your favorite backdoor implemented. So what are the threats? Well, the repository server itself is hosted somewhere and hopefully not yet compromised. We're not sure about that. It is, after all, a Unix machine, which has every now and then some exploitable software. Then, as just mentioned, the transport link between the repository and the client is not secured or is not validated at the moment. This has already been changed upstream in OPAM 2.0. The certificate will be validated. What an attacker might do is to inject malicious dependencies, so arbitrary dependencies on your favorite new package, which is just a backdoor implementation. Or add some stuff to the build recipes, which open a network connection or open a network server, or inject even source code, which is malicious, by adding some new extra patches to the thing. Another person in the middle could just do a targeted attack on a client and just do a rollback attack, so prevent updates of the repository for a specific user, which is also interesting if one of the packages has actually some security problems to prevent some specific client from updating that. So these are the threats we want to cope with, and we want to solve with having Conex. Conex is based on the update framework developed by some people of the Tor team back in 2010. We want to get some sensible security into the whole workflow and process. The main goal is to not have more complexity on the client side, because if you have more complexity on the client side, it is likely that the client will just ignore, like you call your wget or you curl with the insecure options. Also, authors, package authors shouldn't be really bothered with too much complications, because otherwise they won't buy into that workflow and into that signing process. The downside is then someone needs to do some additional work. I mean, it's clear someone needs to do that. And it turns out that the janitors will need to do some more work, but hopefully we will get some tooling to automate most of that work. One crucial design problem is also to explicitly deal with key compromises. So I expect that people lose their keys, and the system is able to deal with that. So if a laptop gets stolen, or if a hard drive fails, you just need to deal with that, and you need to design a crypto system nowadays with doing so, and not using some arbitrary mechanism like expiry dates or unknown signatures or certificate revocation lists or so, which turned out to be very fragile. So in the end, what I want is that it is actually signed, and the client can be sure that it's installed what it is supposed to have installed, what the author intended to have. So the resources, so we will need to add some more files, some more metadata files to the OPAM repository. So each package will have its authorized owners or owner. And the janitors are still in charge of the package names and the resource of package names. So they will hand out the names of the packages to the users, so that Gabriel is allowed to use the name whatever Merlin, and nobody else is able to use the name Merlin. And once you are an owner of a package, which you can establish by asking the janitors, by opening a pull request on the OPAM repository, you can modify anything and publish new releases, retract old releases, and add new dependencies, remove dependencies of the released versions. But you will have to sign those things. What is the trust? How does the trust establishment of the trust look like? Well, both authors and janitors will need to generate private and public key pairs, which are stored in the repository, the public part of that. The initial set of janitors will be distributed with OPAM itself to distribute, but the list of janitors, or the set of janitors, is dynamic, so it must be signed by the initial set, so by the stuff distributed with OPAM, but apart from that, we can add and remove janitors. And clients verify signatures on updates, so it is pretty clear. That is basically what we want to have. Yeah. The repository itself, so we will add files, so each author and each janitor has public keys. Each package will contain an authorization file, which is signed by the janitors, and contains the set of authors who are authorized for that package. Each package will also contain a list set of releases, which is signed by the owner themselves. Each release itself will contain a checksum file, which is digest over all files of the release. And all files means the OPAM file itself, which includes the build instructions, all the patches which are part of that, and the archive files. And that checksum file is then also signed by the owner of the package. And as mentioned earlier, we have those janitors, and we still want to have them because we need them. And they can still sign off new dependencies and fix packages, but a single janitor on its own will not be able to push through such a commit, but will need to have a sign off from a quorum of janitors, because otherwise a single janitor is a bit too powerful and can basically subvert the entire security and can modify arbitrary packages again. Janitors themselves are just a team, a so-called team, and teams is just an indirection on the naming. So we will have teams, which is a map from name, so it shares the same namespace as the authors and the janitors to a set of authors. And the owner of a package can either be a team or an author, or actually a set of teams and authors. And teams will also likely be useful for bigger projects which host a lot of packages, like Mirage OS or OCaml Pro or Jane Street or whatever. Then what we actually will sign is not each individual file, but a collection of resource type, name, and digest, a so-called index, and each author and each janitor has their own index. And this has several advantages. We don't need as many public key operations as otherwise. Each author can vouch for multiple versions of the same resource, which is crucial if we require a quorum and need to add members to a team or so on. And we will prevent merge conflicts for that. Briefly, some demo. So there's a command line version called Conex, where I can then generate, for example, a private key for the user foobar. Then I have the private key. Now I can generate a public key. I can sign the public key. I can sign the key foobar.
Well, I think it's no longer generated, right?
Oh, yes, thank you. So now it is, now we have here in the repository a key of foobar, which is actually a file containing only the ID and the name. Then we have an temp Conex index foobar. We have the actual index file, which contains the resources, the list of resources here, and then a signature of that file. Now we can populate a bit the repository. Then we can Conex verify. Conex verify now complains that we are missing a lot of signatures, and actually there's a package which doesn't have any authorization and so on. So we can actually claim where claim is only generates and sign, so we can claim the package TLS for the user foobar. That one is now assigned by the user foobar, so it's not valid anymore, not yet valid because we don't have the janitors. So let me quickly generate some janitors. 3 janitors, foobar and buzz. Now I can Conex verify those, and I have to so now the generators themselves have public keys as well, and they cross-sign each other, so they are actually valid keys for those, and the team generators is also a valid team. What else? So now I want to sign the authorization of TLS. And now if I verify it, I can see that the authorization has also been, is also there. So here I now have here a limited but valid OPAM repository, which contains exactly 1 package and multiple releases, and that one is authorized. Well, the authorization file claims that foobar is authorized to sign those. So now the user foobar can actually do the releases, so it can tell that, oh, I have 2 releases now done, and then Conex still complains because there are 3 releases of the very same package, and inside of the releases we only have 2 versions of those. So if I now remove the version which I haven't yet released, so which is not there yet, then actually it is valid. Yes, I will, yeah, and then I can sign that, and I can sign the release. So the design is basically that we have only a single connection and everything is stored in the open repository, because otherwise we have problems with multiple connections, and one of them might fail. There's the workflow should be similar to the one we have at the moment with generators and authors and so on. The deployment is a question of having OPAM 2.0 released in order to get some validation hook and compilers as packages. We can have coexisting packages which are signed and which are unsigned. And if a package uses signing, so if we have an authorization and releases, then no unsigned releases will be accepted. The status, we have the basic library implemented in now in a version where we are both happy with that. We need to still work a bit on that, and likely need some help, especially in code review, some automated tools, and some changes to OPAM are also needed. But to conclude here, we developed a design for that and we implemented it. It seems to be possible and to enable the same workflow as before. It is much easier than our initial proposal, which was from June 2015, so it's much less complex. It is not bound to OPAM or Git or GitHub, so it can be actually reused for other data repositories as well. There's no need to trust the repository server. And we can verify both on a clone, so on an OPAM init of the initial repository, but also on updates. And it's also not connected to the main, it's not tightly connected to the main repository, but we can also use it for other repositories. That's it.
Any questions? So I have a question to start the question process. If I want to modify the metadata of a package, and maybe I'm a janitor, it's not my package. If I understand correctly, I have two choices. Either I send an email to the author saying, do this change for me, please, or I get the quorum. And what do you think will be the most common workflow? Maybe one of them is better for some kind of changes?
Well, you can do as anyone, you can propose a PR to the thing and then inform either the author or a set of janitors to sign that off. And once that is that has enough signatures, we can just merge a pull request. And I believe it depends on the package. So some package authors are responding very, very fast. So they will usually sign that off. But for other packages, it is the case that the janitors have to wait for weeks until getting some notification for that. So it will depend.
How do you think we should bootstrap this? So with the 4,000 packages in right now, should we use Debian or FreeBSD signatures to import the initial working set, or should we just open up a new OPAM repository and start from scratch?
Oh, we can just continue with the current OPAM repository.